All right, physics class. This is your first lesson of distance learning. It's for Monday, April the 13th, and it is due on Monday, April the 27th, 2 weeks from now. But don't put these off. If they pile up, that's going to be a problem for you. So this is actually a review of a lesson that we did the week before school closed. And so it's going to be a way for us to kind of get back into the swing of doing physics, and then we'll move forward from there. So we're going to deal with forces and Newton's first law. So what is a force? A force is a push or a pull. A force does not need to cause an object to move. The unit of measure for force is called a Newton, which has the abbreviation N. And the abbreviation for force is F. So we will go ahead and let's just go ahead to the next slide then. So if the forces in opposing directions are equal, we say they are balanced. So these two forces are balanced. So Stick Boy is pushing on the box to the right with 5 newtons of force. Now something's pushing back with 5 newtons of force. And most likely thing is, if you don't see anything there, it's probably the friction force of the floor. The floor creates an opposing force called friction, and that makes it more difficult to push the box. So if the forces on an object are balanced, then the object is doing one of two things. It's either not moving, or it's moving at a steady velocity. Now, really, the first one is the same as the second. Not moving is moving at a steady velocity. It means you're moving at 0 meters per second. But we kind of break them into two different concepts there. So it's either not moving or it's moving at a steady velocity. Okay, so this one's tricky. Because oftentimes when students hear that the forces are balanced, they think, okay, pushing 5 newtons this way, 5 newtons that way, the object must not be moving. But it can be moving. It just isn't speeding up, slowing down, or changing direction. That is accelerating. We'll get to that in just a minute. It's got to be moving at a steady velocity. So forces are balanced. It's either not moving at all or it's moving at a steady velocity. If the forces in both directions are not equal, we say they are unbalanced. If forces on an object are not balanced, then the object is accelerating. That's the only thing that it can be doing. So let's talk about what that means. Acceleration is any change in velocity. Acceleration is a vector, so it can measure both the magnitude, that is the number value of the acceleration, and the direction. There are 3 ways an object can accelerate. It can either speed up, slow down, or change directions. And it could be changing directions without speeding up or slowing down. Just the fact that it's changing directions is an acceleration. Forces. Forces are vectors. Forces can be added. If Stick Boy pushes with 10 newtons of force and Stick Girl pulls with 5 newtons of force in the same direction, then the total force is 10 plus 5, which equals 15. So forces can just simply linearly be added together, just like any two numbers. In this example, 15 newtons is called a net force. It's a combination of the two forces that those two people are putting on the box. That's a net force. Okay, forces can be subtracted. If Stick Boy pushes with 10 newtons of force and Stick Girl pushes with 6 newtons of force in the opposite direction, then the total force on the box is 10 minus 6 equals 4 newtons, and it's going in the direction of the larger of the two forces. So in this case, it would be going to the right. So what's a free body diagram? A free body diagram simply uses a simple box to represent the net forces on an object. In 2 dimensions, forces are balanced when opposing forces are equal. So if you look at that free body diagram above, these are balanced forces. The 5 newtons on the left is balanced by 5 newtons on the right. Those are opposing directions. And the 3 newtons on the top are balanced by the 3 newtons on the bottom. Those are opposing directions. So those would be balanced forces. Now that box could be anything. It could be a car, it could be a person's body, it could be any object, but it's simply represented as just a simple box, and it's showing how the forces are affecting that object. What is mass? Mass is the amount of matter, that is stuff, in an object, or that an object has in it. The amount of matter your body has in it does not change whether you're on Earth or in outer space. So your mass never changes anywhere in the universe. So the example down there, the birthday girl has a mass of 20 kilograms, whether she is on Earth or floating in outer space. What are the units of measure of mass? The basic unit of measure of mass is the gram. One large paper clip has a mass of 1 gram. Usually we use a measure of 1,000 grams called a kilogram. So in chemistry, we tend to be dealing with smaller amounts. We usually deal with grams. In physics, we usually deal with kilograms. The abbreviations are mass is small m, grams is small g, and kilograms is small kg. Your mass never changes anywhere in the universe. Force equals mass times acceleration. And the formula is force equals mass times acceleration, F equals ma, where F is force, mass is measured in kilograms, and acceleration is measured in meters per second squared or meters per second per second. In this class during distance learning, we're not going to get into math or numbers any more than we really have to. We'll try to deal with things conceptually. There will be some times when it is necessary to talk about numbers, particularly with waves and some other things, but as long as I can just keep things conceptual, that is without numbers, I will do that. What is gravity? Gravity is an attractive force between two or more objects. So I always tell students to think of it as gravity. Gravity. That is two people grab onto each other. So remember to think of gravity as gravity because you and someone you like, two people, want to grab each other. What determines the force of gravity? The force of gravity depends on, one, the mass of the objects. The more mass means more gravity. So the Earth has a lot more gravitational pull on it than you do. The fact that you're pulled to the Earth is more because of the Earth than it is because of you. But you're pulled towards each other. So the more massive object has more gravity, and the distance between the two objects. So the distance, longer distance, greater distance means less gravity. In other words, if you're 1 billion miles out in space away from the Earth, you will hardly feel the Earth's gravitational pull at all. What is weight? The force of gravity on an object is called its weight. So weight is measured here in the United States, we measure our weights in pounds. In the metric system, it can be measured in newtons. So newtons is a measure of weight. So weight is a force. Keep that in mind. It is a force. What is the formula for weight on Earth? Weight is the attractive force between an object and Earth. To compute weight using the mass of an object, use the formula W equals mg, where W equals the weight, m is the mass in kilograms, and g is the gravitational acceleration of 10 meters per second squared. If you look at that equation carefully, you notice it's just a special application of F equals ma, where weight is a force, so that's the F, mass is mass, and gravitational acceleration g is a form of acceleration. So W equals mg is F equals ma. What is the acceleration of gravity? Gravity will pull objects with different masses to Earth at the same acceleration. Only air resistance causes objects to fall at different rates. So we've talked about that many times. The acceleration of gravity is g equals 10 meters per second or meters per second squared. But more precisely, it's 9.81 meters per second squared. Okay, now we're going to move into Newton's 3 laws. And today we're going to just cover the first law, and then we actually did this about 3 days before school closed. So the first law is an object at rest remains at rest, and an object in motion remains in motion, that is constant velocity, unless acted upon by an outside force. So in other words, objects keep doing whatever it is they're doing. If they're moving at a steady velocity, they'll keep doing that. If they're standing still, they'll keep doing that. The only way to get them to change is by putting a force on them. If you want to get an object that's moving to stop or speed up, you have to put a force on it and then it will accelerate. If you want an object that's not moving to start moving, you have to put a force on it to get it to move. What you do not have to do, and this is a key concept of key point of confusion, if an object is moving at a steady velocity, you do not have to keep putting a force on it to keep it moving. As long as nothing acts against it, it will keep moving at that steady velocity. The way to always think of that mentally is think of a bowling ball moving through outer space. There's nothing out there to stop it. It's just moving freely. It's moving at a constant velocity. And it will continue to move at that constant velocity forever unless some force acts on it. You do not have to keep pushing the bowling ball in outer space to keep it moving. It will just naturally keep moving forever. Okay, the second and third laws we'll talk about in the next couple of days. So what is inertia? So the first law of motion is an object at rest remains at rest, and an object in motion remains in motion, constant velocity, unless acted upon by an outside force. This is known as the law of inertia. That's the way the word is pronounced. Iner, and the TIA is pronounced like a sh, inertia. Inertia depends only on the mass of the object. It doesn't depend on how fast it's going or how big it is. It's just purely on how much mass that it has. So what is inertia? Well, when Stick Boy tries to push a car that is standing still, it is hard to get the car going. But when Stick Boy tries to stop a car that's already rolling, it's hard to stop. So that's inertia. So in other words, if something is big and heavy like a car, it's hard to change whatever its state of motion is. If it's not moving, it doesn't want to start moving. It's really hard to get it to start moving. But if it's already moving, that car's already rolling, it's really hard to get it to stop. It doesn't want to stop moving. So whatever it is doing, it doesn't want to change if it's a big, heavy object. It's a lighter object, not so much so. It's easier to stop it and start. Okay, so that takes care of our first short little lecture. There's another video for you to watch. You've seen the other video before, but I think it's a good video explaining Newton's first law. So watch these two videos and answer the questions. If there are questions or problem sets that I give you that might be challenging or difficult to answer the questions, I will give you solutions online just like this. I'll record them. But these are really questions that just require that you watch the videos and pay attention to them. That's all I'm asking you to do. So go ahead and do that. Write your answers on lined paper and email them to me or submit them to me through Canvas. And that will be your first assignment. Again, this is due in 2 weeks, approximately 2 weeks on Monday, April the 27th. All right, take care, and we'll see you again tomorrow.